Good morning, students. We are discussing in the previous video measurement of length, and during the measurement of length, we had discussed what is length, what are the different methods for the measurement of length. In that context, we had discussed direct methods, indirect methods. In indirect method of measurement of length, we had discussed parallax, what is parallax, and now today we are going to discuss the use of parallax method in determining the distance of the planet from the surface of the earth, then size of the planet. These two things we will discuss by the help of parallax method. After that, we will discuss the Copernicus method and Kepler method for measuring the distance of the inferior planet and superior planet from the sun. So today we will see these methods. So let us discuss about the application of parallax method in finding distance of the planet. So first application of parallax method, distance of planet. Distance of planet. This thing we will discuss. For discussing this, I am going to draw the diagram. Look at here. This is our earth. This is earth, and this is planet, position of planet P. On the surface of the earth there are two observatories. Observatories means we are observing the planet from these 2 points. This observatory is named as A and this observatory is named as B. This is the line of sight for the first planet. This is line of sight for the second planet. And planet is situated somewhere. Here the planet is situated. This distance is P. Now this is the center O. Center O of the earth. From the planet, this distance is capital D. With this distance we have to find this distance. Capital D we have to find. Now let us suppose an arc ACB. An arc ACB and the chord AB. This is chord AB. The measurement of this chord AB is B. B is the length of chord AB. So look at this diagram. This angle, that is parallax angle or parallel angle, this angle is theta. So I am describing this diagram. First of all, I am describing this diagram. Clearly I am describing this diagram, and after that we are going on our calculation and use of parallax method to find this distance d, how this distance d can be calculated by the help of parallax method. So look at here, we had supposed this, the earth having center O. On the surface of the earth, we had chosen two stations where two observatories are there. From these 2 points A and B, we are observing the planet. So from the first observatory, our line of sight is AP, and from the second observatory, our line of sight is BP. Both the line of sights are making an angle of theta with each other, which is parallelical angle or parallax angle. Now we had joined point P with center of the earth O, that is the PO, which is the distance of separation of the planet from the center of the earth. Now we had taken an arc ACB and chord AB. The chord AB has length B. Now look at here, it is very important assumption or imagination which we have to adopt during our calculation, during our derivation. Since the planet is very far away from the surface of the earth, so we can consider AB, that is AB is equal to arc ACB. AB is equal to arc ACB. Since this distance is very large, so ACB is considered as AB, which is the length of the chord, a small b. And the second thing is that OP is considered as this distance. OP is considered as CP. OB is considered as CP. CP and OP, because they are very close to each other, since the planet is very far away, so OP is considered as CP. So by doing these assumptions, by assuming these things, we are doing our calculation. So first of all, we will calculate theta in radian, and this theta in radian is equal to arc upon radius. So arc upon radius, that is arc ACB upon radius C. Arc ACB, we had assumed that arc ACB is approximately equal to chord. Arc ACB is approximately equal to chord AB, and we will assume it as B. We will assume it as B, and CP is approximately equal to OP. CP is approximately equal to OC. CP is approximately equal to CP. CP is approximately equal to OP. CP is approximately equal to OP, and it is equal to D. Since planet is very far off, so CP is CP. This point C is in the middle of this arc. CP, that is equal to the distance of this point P from the center OP, and this distance OP we had considered as capital D. That is the distance. Now look at here, we had assumed that theta in radian is equal to arc upon radius. So length of the arc, theta is equal to length of the arc small b, and the radius d small d, or we can consider as capital D is equal to B upon theta. Capital D is equal to B upon theta. Very good. So here, by knowing the separation between two observatories, by knowing the separation between two observatories on the surface of the earth, that is a small b, and the angle parallaxical, by measuring the parallaxical angle, approximate measurement of the parallaxical angle, by knowing these two values, distance between these two observatories and the angle between the line of sight, two line of sight, if we are knowing these two values, then we can easily find the separation of the planet from the surface of the earth. Since it is indirect method, so we will get the approximate value of the distance of the planet from the surface of the earth by this method. So this is all about the distance of the planet from the surface of the earth. Now second one is the size of the planet. Size of the planet. Second one is size of the planet. Second thing, we will calculate size of the planet. In the first case, we have calculated the distance of the planet from the surface of the earth. Now in this case, we will interested to find out the diameter of the planet. Diameter of the planet we are interested to find out, and in this method also, in this case also, we are going to apply the parallax method, but there is a little change as from case 1. In case 2, at a given point, in case first there are two observatories on the surface of the earth, but in case 2 there is a single observer on the surface of the earth, and that single observer is looking at two different points on the planet, which is d distance apart from the earth. So there are two line of sights, but the parallaxical angle is going to be formed at the earth, at the surface of the earth. So I want to make it clear from the diagram. Look at here. This is the surface of the earth, and here there is point P where there is an observer. This is earth, and this is the position of the planet. This is the position of the planet. Look at here. This is one line of sight. Suppose this is OA, PA and PB, and the separation, this is the diameter, and this separation between the two planets is a small d. A small d is the separation between two planets. From the center of the planet, let us assume this distance is capital D. This distance is capital D, which we had measured in the previous case, and this is the parallaxical angle or parallax angle, or the angle between two line of sights at the surface of the earth. Now what things we are knowing here? From the previous calculation, we have the idea about the separation of the planet from the surface of the earth, that is capital D, and we can easily measure the angle between two line of sights, that is alpha. Alpha is the angle between two line of sights. So from here, that is the same thing, arc upon radius. Since the planet is very far off, so this arc is considered as AB. the diameter AB, and this angle arc upon radius. Arc upon radius means radius. This is the arc, and this is the arc, and the capital D. This distance capital D. This is the radius. Capital D we can calculate. And since the planet is very far off, so this arc is considered as this line AB. So we can find out as alpha is equal to the small d upon capital D, or we can calculate a small d is equal to alpha into capital D. So by knowing the value of alpha, and alpha is equal to what? Angle that the diameter of the planet makes at point P on the earth, and D is the distance, known distance from the planet. Capital D is the distance of known distance from the planet. So by the help of parallax method in this way, we can find the separation or size of the planet. So these two things are the use of parallax method in determining the separation of the planet. These all things are approximate value. We are not going to get the exact value, because we are taking the quantities. We are various approximations. We are assuming, we are considering in our derivations and calculations. So we are going to get the approximate value, not the accurate value. Now, second one is Copernicus method, and this Copernicus method is used to find the distance of an inferior planet from the sun. Distance of inferior planet from the sun. So let us know about what is the meaning of inferior planet. Inferior planets are considered as those planets whose radius of revolution around the sun is smaller than the radius of revolution of the earth. Means the orbit of that planets are smaller as compared to the orbit of the earth. Means whatever the orbit the earth is prescribing or describing around the sun, the orbit of these planets, what are that planets which are inferior than the earth are Mars and Venus, and Mars and Venus has a smaller orbit, a smaller radius as compared to the orbit of the earth. So these planets are considered as inferior planets. So distance of, next one is Copernicus method. Second one is distance of an inferior planet. Distance of an inferior planet from the sun. That is called as Copernicus method. This is called as Copernicus method. This is also an indirect method to measure the distance of, means these distances cannot be measured by the help of direct instruments. So these methods are applied for the measurement, and you have the idea of these methods. As a student of physics, you must have the ideas of these methods, how to measure these distances. So distance, that is Copernicus method. So let us do our discussion. This is the radius of the earth. Sun is at the center, and this is the radius of the earth. Sun is at the center, and this is the radius of one of the inferior planet. This is the radius of one of the inferior planet. The planet is situated here. I am joining this. This is the position of the earth. This is the position of the earth. This is the position of the planet. This is making an angle of 90 degree. This radius is denoted by RPS, radius of planet with respect to sun. This is RES, radius of earth with respect to sun, and this can be given as RPE. RPE, radius of the planet with respect to earth. Now, the angle which is subtended by the earth for the planet with respect to sun, the angle which is subtended by the planet with respect to sun, the angle which is respected, the angle which is subtended by the planet from the earth, observer at the earth with respect to sun, this angle is given by angle of elongation, that is epsilon, angle of elongation or planet's elongation. This is the angular distance of the planet from the sun as observed from the earth. Epsilon is angular distance of the planet from the sun as observed from earth. Angular distance of the planet from the sun as observed from the earth, or in other language you can say that the angle between the earth and the sun direction, the angle between earth and sun direction and earth and planet direction, the angle between earth and sun direction and earth and planet direction. In easy language you can understand it, the angle between earth and sun and earth and planet, that is called as epsilon, and this is called as planet's elongation. Planet's elongation. This is called as planet's elongation. Clear? So this is the angular distance or angular separation. Now from here we are going to calculate, first of all, this is a right angle triangle, EST is a right angle triangle, and from this right angle triangle we can find out the value of sine epsilon, sine of angle of elongation, and look at here, it is perpendicular, it is base and it is hypotenuse. So perpendicular upon hypotenuse, it means that RPS upon RPS upon RES, and RES can be supposed as 1 astronomical unit. Here I will give it value later on. 1 astronomical unit. The distance between earth and the sun can be measured as 1 astronomical unit, and its value we will discuss later on, and we will define it also. So RPS from here, RPS planet sun distance, planet sun distance, planet sun distance is equal to sine epsilon into 1 AU, sine epsilon into 1 AU. Clear, students? This is simple mathematics. Now we will find out the cos epsilon. Now we will find out cos epsilon. Cos epsilon is equal to, that is equal to base upon hypotenuse, and base is RPE upon RES. RES you are knowing, one astronomical unit. So we can put here RPE upon 1 astronomical unit. And from here RPE can be calculated as RPE planet earth distance, planet earth distance, planet earth distance, that is equal to cos epsilon, cos epsilon into 1 astronomical unit, cos epsilon upon 1 astronomical unit. Now these two things we have calculated. Now we are interested to find the value of RPE. RPE, how you can find the value of RPE? I am just elaborating you how to find the value of RPE. We are not describing here. To find RPE, to find RPE. How to find RPE? To find RPE. How to find RPE? To find RPE, this distance, what we will do? As you know that radar is a device, radar is a machinery or device which send radio signals. So from the surface of the earth, a radio signal is sent for this planet. And suppose that radio signal is returning back in time t, in time t. So what we will do, we will first of all that radio signal will go at point P and then return back. So it will cover 2 RPE, distance of 2 RPE, 2 RPE, this distance. Suppose a radar is sending a signal and that signal is going to point P, and after striking the planet it is returning back on the surface of the earth, or at this point it is returning back. So it is covering how much distance? RPE plus RPE, 2 RPE, and c is the velocity of the radio signal, and the total time is taken t. C is total time is t. So in this case RPE is equal to Ct upon 2. RPE is equal to Ct upon 2. C is what? Velocity of light. C is equal to 3 into 10 to the power 8 meter per second, or 3 into 10 to the power 5 kilometer per second. And T is the time. T is the time taken by the signal for journey from the earth to planet and back to earth. T is equal to time for radio signal. Time for radio signal. It is time for radio signal to go to the planet and return back to the earth. So by calculating this time, and we are knowing the velocity of the radio signal, putting these two values here, we can calculate the value of RPE. Now if we are getting the value of RPE, then it is easily to calculate the value of epsilon naught. If you are knowing RPE and 1 astronomical unit. What is the value of 1 astronomical unit? 1 astronomical unit is 1.496 into 10 to the power 8 kilometer, or you can say that 1.5 into 10 to the power 8 kilometer. Means putting the value of 1 astronomical unit and knowing the value of RPE, by this method knowing the value of RPE, you can find the value of cos epsilon, and from here you can get the value of epsilon. And as you are knowing the value of epsilon, then it is easier for you to calculate the value of RPS and RES. Both the values you can calculate easily. So this is the Copernicus method for finding the distance of an inferior planet from the sun. Distance of inferior planet from the sun. Now our next discussion is distance of superior planet. Distance of superior planet from sun. Distance of superior planet from sun, and this method is known as Kepler's method. Kepler's method. As you are knowing, Kepler was the scientist who had observed the planetary motion and given his 3 laws regarding the Kepler regarding the planetary motion. He had given the 3 laws. So one of the law in the 3 laws is law of radius or law of periods. And this law of periods tells that the square of time of revolution of a planet around the sun is proportional to the cube of semi-major axis. That is, a square of time period is cube of semi-major axis. And from here you can say that T1 square upon T2 square is equal to A1 cube upon A2 cube. Suppose you are knowing the time period of we are comparing it for 2 planets. Two planets are from the surface of the earth. You are knowing the time period for one planet, the other planet is unknown. You are knowing these 2 values, and from these 2 values, by the help of Kepler method, you can calculate the distance of the planet from the sun. You can calculate the separation of the planet. Next one is triangulation method. Fourth one is triangulation method. It is very easy one. You had studied in class 9th or class 10th about trigonometry, and in trigonometry you used to find the height of the object on the basis of angle of elevation, angle of depression. So the same concept we will apply here in triangulation method to find the height of an accessible object and to find the height of inaccessible object. So what is the meaning of accessible object? The accessible objects are those objects whose height can be determined. This is height of the tree, height of the building top, means you can see the top, you can reach the top of that objects. But the inaccessible objects are those objects whose top cannot be reached, such as height of the mountain, height of the aeroplane which is flying in the sky. So these are the inaccessible objects, means from the surface of the earth you can't able to reach the height of that objects, so they are called as inaccessible objects. And the accessible objects are those objects at the top of which, or at the top of that objects, you can easily reach. So first one is to measure height of an accessible object. Height of an accessible, height of an accessible object. To measure height of an accessible object, suppose A, B and A, B and C. It is making an angle. This is a right angle triangle, and if alpha is the angle of elevation and this is height h, this is the height h you want to know, and you can easily measure this distance x. You can easily measure this distance x. So from right angle triangle ACB, from right triangle ACB, in this right triangle we can easily calculate tan alpha is equal to perpendicular upon base, and you can find out perpendicular h upon base x, and from here h is equal to x tan alpha. X tan alpha. In this way you can find the height of an accessible object by using simple trigonometry. Okay? Clear to you? It is clear to you all. So this is all about today's video, and in the next video we will measure the height of inaccessible object, and after that we will use some other methods, that is laser method, radar method, sonar method, to use measure indirect distances, and after that we will discuss the indirect methods for the measurement of size of a smaller objects, that is size of the atoms or size of the nucleus. So thank you students, have a good day.